So today we have a very important integral e power x sin x dx. So let's say that it is equal to I. So in this kind of problem we are going to use the ILATE rule of integration, where I stands for inverse, L for log, A for algebraic, T for trigonometric, and E for exponential. So ILATE rule is used for determining the first and the second function. Suppose uv dx. So we have to decide that which function will be the first function or the u, or which function will be the second function or the v. So here we can see that if you see the trend here, the trigonometric function is coming first and then we are getting the exponential function. So we can say that we have to take here u as a trigonometric function and v as the exponential function. So integral of uv dx will be directly written as integral of, so we'll represent the integral as sin x e power x dx. So we already know that the value of u v dx is equal to u integral of v dx minus differential of u integral of v. So let's put the values in this formula. We'll get sin x e power x dx equals sin x e power x dx minus differential of u, that is the differential of sin x, will be cos x, integral of e power x, that is e power x. So integral of e power x, again it will be e power x sin x minus e power x sin x plus c, the constant of integration. So I'm going to rewrite this equation as it will be e power x sin x minus integral of cos x e power x dx. So there was a slight error in the last step. So we're going to replace this by I. Now we're going to use the uv rule again here for this integral. So I can be written as e power x sin x minus times cos x e power x dx minus differential of cos x will be minus sin x and e power x dx. I equals e power x sin x minus cos x e power x plus integral of sin x e power x dx. Now on carefully observing that, we'll get this function again, so we replace this with I. So we can write I equals e power x sin x minus cos x e power x minus I. That was the function which we have taken earlier. So now what we'll do, we'll shift the I on the left hand side of the equation. We'll get 2I equals e power x into sin x plus sin x minus cos x plus the constant of integration. So I will be equal to e power x into sin x minus cos x upon 2 plus the constant of integration. So I can say that I equal to e power x into sin x minus cos x upon 2 plus some constant of integration k, that is equal to c by 2. So we have solved this equation.